Hi, good morning, everyone. I hope you're doing well out there. I just wanted to give you one more lecture, a little bonus lecture, a quick review for the final exam on chapters 10 and 11. Just to let you know, the exam will be available on Canvas from this Wednesday at 10 a.m. until Friday at 11:59 p.m. So you'll have 3 days over which you can take it. Unfortunately, due to grading constraints, I won't be able to open it up past this time. It will look and feel very much like the last two exams that we have. It will have a 50-minute time limit. It will be roughly the same length. It will just only cover these two chapters. So, if you have any questions, please feel free to email me. Also, I might like to say is that you should check Canvas grades and make sure everything is correct. And let me know if there's any problems. I'll try to fix those as soon as I can. All right, so this should be pretty short. Let's jump into it. So, chapter 10, this was all about the habitable zone. So in the first section, 10.1, we defined the habitable zone. We talked a little bit about its evolution, how it changes with age, what the boundaries are, and we talked a little bit about life outside the habitable zone. So where were places outside that, or how can we extend it? We then focused in the next section on a case study. We looked at Venus's runaway greenhouse effect. So you should be familiar with this. Why there was no CO2 cycle, and where did the water go? These were things we talked about that you should be familiar with. Really looking at how Venus is super hot. It's technically outside of the habitable zone, but how these different things can affect it. So this led us to our next section, which was really talking about planetary factors that affect habitability in terms of the habitable zone. So this can extend the edges. What are the factors we need? So it needs to be inside the habitable zone. It also needs to have internal heat for plate tectonics. And that'll give us a CO2 cycle everything through. It also needs an atmosphere that is dense enough to have enough pressure for liquid water to exist. So we need liquid water, we need plate tectonics, internal heat, and we can look at Venus and Mars for examples of things that don't have those, or maybe too much of them. So we then move to 10.4, looking at the evolution of the sun and the sun's habitable zone over time. The sun is going to get brighter. It's going to get bigger. That's going to cause the habitable zone to get wider and extend out. This may affect Earth's future habitability in terms of the moist greenhouse effect. That might really trouble the climate here. And then we talked a little bit about the long-term fate of the universe in there too. 10.5, that was all about global warming. Some things you could focus on there are the human cause. What's the evidence that it's human caused? And what are the consequences? Besides warming, there are other consequences: sea level rise, ocean acidification, more intense weather. All of those things. That's about it for chapter 10. So, really looking at habitable zones, how they evolve, how they affect life on a planet, how the planet affects the habitable zone. So, there's sort of a give and take there. And then we moved on to chapter 11. So, the whole focus here was looking at exoplanets, exostar systems. So we sort of started with the stars. We talked about stellar classification. Remember, that's that OB, a fine guy or gal, and kiss me, OBAFGKM. The stellar classification system. We talked about which stars are good for habitability. They need to be older generations of stars, but really they need to be not too big and not too small. It looks like the G and K type stars are the best. They're sort of in the middle. Maybe F-type stars. If they're too big, they don't live long enough. They're too bright. They have lots of ultraviolet radiation. If they're too small, the orbits are very small. Planets will become tidally locked. So not too big, not too small. And then we talked about exoplanet detection methods. There were 3 of them. The transit method, astrometry, and the Doppler shift method. You should be familiar with all of those. So what are they? How do they work? And what can they tell us about the exoplanets? So do they give us radius, mass, period of their orbit, distance, things like that? The next thing we talked about is what are the properties of the confirmed exoplanets that we've found. Let me see if I can spell today. What are their properties? And really we looked at that compared to our own solar system. They tend to be finding bigger planets with closer orbits, also more eccentric orbits. Now there are some confirmation biases, or detection biases, I should say, that lead us to find bigger planets. You should be able to explain that. This led us to the question, are Earth-like planets systems common? And it looks like small mass planets are more common than big planets. Probably 70% of the stars out there have planets, so it looks like, at least in broad strokes, Earth-like planets are probably very likely. We then went on and talked about the habitability of various exoplanets. One thing we talked about there that was kind of different were some of the sort of non-standard planets that might exist. Super Earths, mini Neptunes, life on moons and rogue or orphan planets. how these can extend our idea of where we might find life. And this led us to something called the rare earth hypothesis, where we said that Earth has some lucky aspects to it. A large moon, Jupiter sitting out there to protect us, just the right size for plate tectonics. We don't know how quote-unquote lucky those things are. The last section there we did not cover. This was more about stars, so this will not be on the exam. I wouldn't expect you to to be able to cover material I didn't cover myself. So that's about it. Again, in broad strokes, Chapter 10, we defined a habitable zone, the region around a star where liquid water could potentially exist on a planet. And then we talked all about ramifications of the habitable zone, how it could change with time, planetary properties that could affect the habitable zone, extend it inward or outward, and what will be the eventual fate of our own habitable zone with a little global warming stuck in there. And then Chapter 11 really focused on exoplanets and other star systems and where we might find life in those other star systems. So 10 and 11 go really well together. Up until this point in the semester, we've looked a lot at where we could find life in our own solar system, and 10 and 11 do a really good job of looking and explaining of where we might find life in other solar systems. So I had a great semester. Let me thank you again, and good luck studying. Please let me know if you have any questions.